Welcome to Flip Lesson 21 for the 7th grade, and today we are bringing back our good old friends, the primes, and understanding how the primes work. So as we look at our primes, we want to understand what is a prime number. And so we have a list of numbers in front of us. We would call those counting numbers. But as we talk about those counting numbers, we know that numbers can be divided into factors, right? So which two numbers multiplied together equal that number. And so as we look at this picture, we kind of get this really long definition, right? But this understanding of this definition can help us understand what a prime number is, right? So prime number, 1, counting number, 2, greater than 1, 3, whose only factors are 1 and the number itself. So as we look at the list in front of us, we want to say, okay, is 1 a prime number? Okay. Is it greater than 1? No, of course it's not greater than 1. So 1 cannot be a prime number. Is 2 a prime number? Okay, it's greater than 1. It's a counting number. We already determined that. What are the factors, right? 2 times 1. Yes, that's a prime number. Okay, 3. Okay, 3 times 1. Anything else? Yes. We get to 4. Is 4 a prime number? No, right? 2 times 2 and also 1 times 4. And so this has 3 factors. So this is not prime. Right? And we can continue down the list and figure things out, but that's what we're working with when it comes to prime numbers. So from here, right, prime, Optimus Prime, Angry Bird Optimus Prime, is asking you a really simple question. It says which of these numbers is prime and which is composite? Wait, what's composite mean? All right, let's take that real quick look. Composite numbers have 3 or more factors. Right? We took a look at that with our example with number 4. Right? Our number 4 we said has all these different factors. Right? Has 2, has 1, has 4. That's a total of 3 factors, and so it's composite. Right? Composite number. Right? All right, let's come back here then and take this as a sample then. Which of these numbers is prime and which is composite? All right, so you got 3 numbers, 16, 17, 18. Tell me if they're prime or composite. And to figure it out, you basically just need to do some simple factorization. All right, hopefully you figured that one out and solved how to do which number is prime. But now we can take this and look at what's known as prime factorization. We've looked at factorization and understanding, 1 times 4 and 2 times 2. That's the example we've used so far, right? But we also want to be able to take numbers and break them down into just prime numbers, right? And so we use 2 methods to do this. One of them we call a factor tree, right? And we even specialize that more. We say that tree's been whittled down into a hockey stick, right? So we have the hockey stick method, though technically it is a type of tree, right? Where we branch down, we think of our smallest prime factor, right? We see this as an even number, so we can put 2 for our prime number. And so 2 times what equals 30? That would be 15, right? And then I can factor a little bit more and say, okay, 15's odd. Well, let's try number 3. Okay, 3 times 5. And now suddenly I'm left with my prime numbers. Right, there's my hockey stick. And I would list my answer going from least to greatest with a list of prime numbers. Right? Now, that is just one method of doing factorization or prime factorization. Right? Sometimes it says the wording will be factor by primes. Right? This is what we would what I've come to call the tower method, right? This is where we continually build on top of each other, right? So as I look at this idea of 81, right, I'm going to factor it down. Okay, it's not even, so I'm not going to start with 2, but I know 3 goes into 81 because 8 plus 1 is 9, so that means it's divisible by 3, right? This is where our divisibility rules comes in real nice. So 3 goes into 81, and that's going to be 27 times, right? And then we continue with our division symbols and towered up. I know 27 is divisible by 3, and I'm going to get a 9 and 3 and then final answer of 3. And so in the end, we see our relationship of 3's. So we'd say 3 times 3 times 3 times 3. All right, so we have that review of factorization. All right, now here comes another picture we haven't necessarily discussed before, but does prime factorization have a connection to the greatest common factor? Okay, we're breaking things down into primes. Is there a connection? All right, let's take a look and see what's going on. I've gone ahead and factored these for us already. All right, so we can see the breakdown of these two numbers. I'll move the 60 over a little so you can see all the steps. So we've broken it down into prime numbers. Right, now common factors, of course, we wouldn't sit here and say 2, 2, right? We only have 3, 4 numbers. So how does this help us with common factors? All right, from here we're going to rearrange our numbers, and I'm going to write my factorization. So it's 2 times 2 times 3 times 3. Right? And then right underneath it, I'm going to put the 60. Right? And so the 60 is going to be 2 times 2 times 3 times 5. Right? Now as we look at this relationship between them, we can quickly see that there's 2 2's. They both share that. They both share this. They both share this. Okay, so how does that point to our GCF? Well, since these are all the same, 1, 2, 3, right, they're all connected, that means if I were to actually solve and take 2 times 2 times 3, I'm going to get an answer of 12, right? 2 times 2 is 4, times 3 is 12, right? And from here, then we would say 2 times 2 times 3 is also 12, right? So we both now know that they both have a common factor of 12. And of course, it's going to, because of this relationship, because of this prime that we just broke down right here, it also reveals that this number 12 is also the greatest common factor. Right? So that's a new approach, a new look at understanding prime factorization and relationships that are going on. Okay. All right. One last thing. So you think you got it? All right. Well, I'll try this one on for size. It says create a list of prime numbers and composite numbers between 40 and 50. All right. So make 2 separate columns. Right. Which ones are the prime numbers? Which ones are the composite numbers? Right. And if you don't get it right, you know those piggies are going to laugh at you. I won't laugh at you, but those piggies will. They always do. Right. Of course, then you just come back and slingshot them and bust them up. All right, that's it for lesson 21.